Okay, so good morning all. We will be starting with linked list today. Am I audible? Can someone just confirm once because I have connected my microphone to some other device right now. I hope yes, right?
Yeah.
Yeah, okay. So linked list. This is like one of the most important topics, and also as in that it's actually really asked in an interview, and we will be treating this not as a data structure right now. We'll be treating this as a game that we'll play, right? Because it's actually not that much of complexity. It's just like you guys need to understand the basics of linked list first, and then just treat it like any other data structure, and then just you need to manipulate it as you like wish to according to the question, which I will tell you. But first, before we go into a linked list, we should understand what exactly like how array is stored in an memory, right? We will start from there. Like, let's say that if I have, let's say uh let me just yeah let's say that I have defined one int ar 4, right? Which is like 1 2 3 4. Fine. 1 2 3 4. Fine. So it's basically, when I mean I have defined this array, right? So this is of fixed size, right? You can't increase or decrease the size of this array, right? It's a fixed sized, right? So it's of fixed size, and there's something like when you type this in the command, when you execute this line, how exactly this is stored in the heap memory. So basically what happens is that there's something array stored in, like whenever you're writing lines of code, whenever you have defined this array, let's say in a heap memory, let's say this is a heap memory, right? This is a heap memory. The elements of array is stored in this way, like this is some element, it is stored in this way, like everything is linked, right? And linked to each other only, right? And you can't increase or decrease the size of it. Fine. So like it's like this is the zeroth element, 1 2 3. So this is the actually how array is stored in a heap memory. Fine. In a heap memory of your device or something, sorry, of your computational unit, it is stored in this way. Fine. So this is a fixed size. You can't increase or decrease the size. You can't manipulate, basically uh, anything. Like we can index wise, we can increase or decrease the size in linked list. Fine, which I will tell you guys. So basically, this is how array is stored. First of all, fine. And even if you like, and instead of int, you can use double. You can use, right. You guys know that, right? You can use double in in C++. We use vector int, right? So in this way, it's same. It's stored in the same way for every kind of data type. Fine, but the array is stored in this way. Fine. Now coming to the linked list, basically. So first of all, what exactly is linked list? Linked list is something like it's kind of a data structure which is kind of connected with each other to a next element, as in the first element knows where the next element is, in where it is stored in the heap. Fine. How? Let me show you guys. Like, let's say that in the linked list, what happens is that this is a heap. Fine. And I have defined one linked list I have defined. Let's say this is the linked list, and I have written 1 2 3 4. So instead of I mean, just don't confuse with this and this. This is different. This is how array is stored. Fine. This is not linked list. This is how array is stored basically, and this is what exactly link looks like for now visualization. But in heap memory, it is stored in this way. Like one will be here somewhere, two will be somewhere here, three will be somewhere here, four will be somewhere here. Fine. So it's not in contiguous manner as like in array we have, right? So basically why it is stored in this way, so that let's say that I need to increase the size of the linked list, like let's say I need to add one five. Also sorry, I didn't mention this. This is also connected in a particular way, right? Because every element knows where the next element is, in which target, in which address. Fine. So it is stored in contagious. It is not stored in contagious manner. And let's say that we need to add one element, right? We can easily add the element, next element. Let's say that we need to add five. We can have five. So five will be stored somewhere here, and then you need to connect it. So you will connect the basically four with this and two with three. Fine. You guys get the point. It, I thought it is, yeah, one, two, three, and this will be four. Fine. So in this way, like basically this is how memory linked list is stored. Fine. So size can be increased at any point of time, unlike array. Fine. Also, uh, now let's see how linked list is actually, defined now, right? Let me just hold on. Okay. So as I said that, so this is how basically a normal linked list looks like. So here you guys can see that every data, every element has, first of all, it has one number where like it stores one data. Fine. And then it also stores something called as next, right? Next is equal to n2, which means that this element knows that its next element is n2. Fine. Just hold on, someone messaged. Oh, it's not in our Telegram group. Never mind. So yeah, so basically every element knows where the next element is, where next element exists. Similarly, N2, whose next is N3, so it knows, okay, it will point to N3. N3, whose next is N4, it will point to N4, and next, and N4's next is null, basically null, as in it is not pointing to anywhere. It's basically a null thing. Right. In C++, we write null pointer, PTR, like in this way. But in Java, we just write null. Fine. So you guys can know the difference between how we will be using it. I will just tell you guys both the ways. In Java and CPP. But this is the basic structure of linked list. Am I clear till now? Like how it is basically uh, getting. Uh, have you guys understood the linked list structure now? Also, if no one asked actually, head, what exactly is head? So let's like whenever we need to, pass any kind of basically in questions, instead of giving us the whole link, like whole linked list, we are given just the head. Head, basically this is the head. So head will be the starting point of any kind of linked list. Head basically tells that what, it signifies that this is a linked list. Fine. Head can be just head, like in a one which will have one element. Head can have basically two elements or more than two, but her head just means that basically it signifies that a linked list is there. We will be dealing with head a lot, right? So this is what exactly the basic data structure is. For now, we also have the tail and all, but we use that in special cases, and it depends on questions to question. Fine. So let's say that, okay, let's say that I will now tell you, I mean, just basics of how we can add one element. Let's say that this is a linked list. Fine. The next of the last, you guys can call it as a tail. Fine, let's write it tail only. Right. Let's say that the last element is tail, and it is pointing to where? Null. Fine. Now, let's say that I have one more, I have declared in a code one more element. Fine. And its value is stored in N5, and it has some memory. Fine. No one knows it. It has a memory, and its next is null. Fine. Whenever, whenever you define linked list element. Let's say that we need to add here, in this case we need to add n5 to this linked list, right? So first, this always you need to define the element first, like you need to make a node n1 n5, any node you need to define the value. Also you need to define where its next is pointing to. For now it is pointing to null because it's the last element, it will be inserted in the last, right? We will see how you can insert it anywhere, but for now just think this. Fine. Now you need to add this, this element to this linked list. What can we do here? Can someone, this also is a null pointer. Fine. Null or null pointer. Let's stick with null pointer. Fine. Now can someone unmute and tell how we can insert this linked list to here according to the given pattern, because this is what you guys need to learn. Seeing the pattern and then using it. Wait, someone just joined. Admit. Yeah. Yeah, can someone just unmute and tell? Just think like how we can add this element in this linked list, ongoing linked list. This is actually really simple. I mean, it's just like it's like a game. I mean, basically you just need to whenever there's question or linked list, you need to draw it out and then just imagine that how you can manipulate the linked list, how you can add or delete any kind of linked list. Fine. For now, I will just tell you, like if you need to add this element, what you can do is that you can just tell, it's very easy. You can just tell the n4 basically where the tail is. You can just tell the tail that, hey tail, listen, just make your next point to n5. So you will update the tail of next, as in I will tell you, as n5. Now what is this? What is this arrow? This basically tells that tail's next should be n5, and this link will be created, and this tail you need to shift. So that will be taken care of in the code. But for now, just see. And in CPP, in obviously in C++, we write in this way. But if we need to write in Java, we write dot instead of arrow. So tail dot next will be n5, and next, and this n5 next will be null pointer. So basically we have joined the whole link and one new element is added. Is that clear for now? Is that clear? It's very easy. We just need to play with these pointers, with these arrows, connect, and maybe in some cases unconnect, and many things, right? So this is what basics of linked list is. Is that fine for everyone?
Yes.
Yeah, yeah, cool, cool. So, some real world applications of linked list. I will just tell you a very common one is basically it's actually used in the browser. Have you guys seen, like in maybe in this let's say in like here you guys may be seeing, okay, you guys are watching this in a meet, Google Meet, right? So in a window you guys have seen these arrows, right? If you are using Chrome, you have seen these arrows, right? The back and the prev button, right? Of the web pages. For the web pages it is used, it is at the top left of any browser, right? Where you click and you go back to the place, right? So basically this is implemented using linked list only. Fine. So basically browser implementation, browser is formation is done using linked list. So this is one of the best real world example of linked list. Also when also it is used in implementation of stacks, right? The linked list is used for implementation of stack. Now you guys will know how when we will be covering the stack and queues, implementation of stacks. Fine. It is also used in, as I said, in browsers. Fine. And what else? Uh, and it is also used in, actually it is also can be used to implement any kind of queues as well, right? So when we are doing stacks and queues, we will learn about how linked list there plays a role. So just for now, just remember this, that what are the examples of linked list. Fine. Now let's go to the code, as in like how we can define this. So let me just show you the code also once. I have already written it because this might be the long class. So I have already written some few things. I will be explaining this. So this is basically for this CPP code, right? So I will tell you step by step. Also, in the questions, in the coding questions, you guys don't need to define the whole linked list and all again and again, because you will be given questions. And let's say that you are given a question of reverse linked list. So basically, you will just, pretend. Not assume that these are the declarations, and as in you just write the functions, right? Like in lead code we don't write the main function, right? So you just need to write the functions, but for now still you need to know how to implement a structure. So we are using a struct here. Okay, struct class, sorry, struct structure. Name is node. So I have defined one node. Let's say that this is a node. Fine, this is a node. Okay, this is done. Int data. There's one data I've defined, and int star next. This is a pointer. Basically, again, I have, I guess, explained the concept of pointer. If you have not seen that video, please go to that lecture. I guess it's in the second lecture. Fine. So I have assumed one next pointer. Fine. I have assumed one next pointer in the node, and again I'm basically this is, if you guys are aware of oops, object oriented programming, I am using the node as a constructor here, basically to create the node. Like this is just a structure. So this node will, input two things: data and next pointer. Fine, as I said, it will have two things: data and next pointer. Fine, so I have just used the constructor here. Fine. So this is how I have, like, till now I have just defined this node, right? Now if we have a vector int array is 1 2 3 4. Fine. Let's say this is one array. Now you basically need to convert this array to linked list. Fine. For now, just assume that is the given array and you need to convert it to a linked list. Fine. You can have, this is really important line. This is actually really important line. Fine. What you are doing here, what you're doing here, you are defining one pointer. Fine, you are, first of all, okay, uh, wait, I have, yeah, so you are basically defining one new node. Fine. The first in parameter is data. You can see that node, when this is called, it goes here, it is the data. Fine, data 1 is equal to data, which means that array 0 is what, 1. So you are defining 1, and there's one null pointer. Just hold on. Yeah. So there's one null point, and the next element should be the next pointer, right? So basically we are just defining this right now. So this is what one is. And now if you see out y, let's say, we will do this array to linked list in the next code, but yeah, for now just forget this, right? Yeah. So whenever when you are printing out the y, like it prints the memory address, basically, because y is a pointer, right? And what exactly is pointer? You I have I have taken that lecture, right? It's just points to the address, right? Like there's one y here, it just points to the address of the next, right? So I mean, it just points to the address, right? So if we have y this data, then it will print the value of the node. Fine. This is what basically the implementation of node linked list is. First, you need to define the node, and then you need to use the node to create the elements. And now, if you do, like, if you use the dot append, let's in the CPP, you can, append the values here. I will tell you that as well. Fine. So for now, this is what is, and this is what, how you define the linked list. Also, now in the, this is a CPP code. Now in the Java, let me also, in the Java code. what you do is that you basically you don't use pointer because there's no concept of pointer, so you remove this pointer, also you in place of this arrow you use void dot data, fine, in Java, and there's no null pointer again, only you use null, right? So this is what basically the Java is. Also, one homework for you guys. uh, we basically use structure here, right? Node. Why can't we use class in place of structure? This goes to the object oriented stuff, but this is really important to know because this is the most asked question. If the interviewer is covering linked list in your interview during your technical round, it can happen that the interviewer may ask you this implementation, that why can't we use class, or if you are defined the node as class, why you're not using a structure, right? One hint I will say that in a real world application in a real world application, class is preferred, fine. Oh, it ruined my flow. Class is preferred instead of using struct. This will be your homework, like why this happens, why this is class, why we are using class basically, and why we are using an instructor and all. Fine, this will be your homework, so please take a note of this. Fine. Now, uh, coming to the next part of this linked list. uh, so yeah, this is done and the implementation is done. Okay, I missed one thing. Also in Java, instead of writing this straight away with data one, you use this dot, this operator dot this here. Fine. You guys can, like as I said, it's if you need to be language specific, you can always do that on your own, because I will just tell you the syntaxes and all. I have defined everything. Like also this thing you won't be using. I mean, at least in lead code practice you won't be using, but you still should know how to define the linked list. This is just the basics of basic. Fine. So please take a note of this homework for you. Fine. Now let's start with something. We need to basically transform an array to linked list. First of all, am I clear till here? Like, is everything fine till now? If anyone has any problem, please, you are welcome to stop me and ask. Fine. So yeah, yeah, we need to basically convert an array to a linked list, right? And let's say that we are given an array. I will type array. We are given an array, right, which is like 2 1 3 8. Fine, let's just assume anything. Someone uh, commented, wait, raised hand, Bunty. Yeah, please ask.
Can I like answer, like try to answer that question?
Which question? Oh, that question.
Yeah.
Yeah, yeah, please do.
Maybe I'm not sure, but
Mhm.
maybe like in this struct, like the classes have like private and public like modifiers and all
Hmm.
basically, and struct don't have that property, like
Exactly.
it's public.
Yeah, 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 yeah. Thank you, thank you. Yeah, that's the thing. When again, as I said, that I won't be going to language specific codes right as of now. Basically, this whole code is written in a public class. Like, let's say it's not written in structure; it's written in class, and in class only, as Bunty said, in classes only we have the properties of using public or private, right? So yeah, that was the answer. It's good, good, very very good job, bro. So array to linked list, fine. Also, others, please, or anyone who is watching the recording, please research on your own as well. Fine. And also, Yeah, I guess just go and research it on your own self because it's more of a object-oriented approach. Array to linked list. Fine. Let's say that we are given this array 2138. Fine. Uh, right. And we need to, convert it to a linked list. Fine. What I can do here, what I can do here is that, let me just copy some things which I have made. So basically, what I can do here is that I can this is what I have to do, right? I have to go, I have to make this, I have to first of all check what all the data values we need in a in a linked list, and there's need to create nodes of each and just need to connect them. Fine. This is what we need to do. What we can do here is that we can first, before going to all of this, we can first start with the basically we can just start with the first element, right? So let's say that we have a head, right? We have a head here. We can have this head here. We have defined two here, and this actually uh, let's say we have another variable mover. It's just let's say it's just a variable for now. Don't assume it that much. Now I have defined this head at 2. I have defined this mover at 2. How we can define 2 as a node here? We can just write. Let me just also code it out here. We can write this code node star uh, node. Let's say we have some other element. We won't be writing this, but for now I will just write this. Like this, basically, this is how you can define a node n as node. This should get the value of 2, right? So this is just a pointing to null, and this is what basically you are defining, right? So this is how you will define it. Now I have my head. I have my head here. Let me write it a little clear. I have my mover here. Mover is just a variable for now. I will come to it, like why we are exactly using it. Mover is just a element. Now we can have one more. We can define now one more new node, basically new node with one and a null as a pointer. So basically, if we define this, we can have one more same thing. It is pointing to null. It has something, right? And I can have one more new pointer. Fine, I can have one new pointer temp here. I can have new pointer temp. Let's say this is a mover, right? I will use temp here. Fine, this is a temp. In the linked list, we will be using temp a lot, so please note it. Right. So now I need to. This is a mover. This has some pointer, right? This is a pointer. This is a temporary, and again a pointer. Fine, which is pointing to null for now, right? Uh, yeah. Also, how you will define this temporary? It's easy. It's easy. I can write node star temp new node with one and null. Fine. Again, also one more thing that new node is one. The star in the if you are doing Java, just ignore the star and you are good to go. Also, if I'm using here CPP, I will write null pointer. If you're using Java, please write null only because null pointer is only in CPP. Fine. Now I need to connect these two elements. How can I connect? What can I use? Like earlier we saw that, right? We can use something called as next, right? Arrow next. How can I connect these two elements? Basically, I can just make this two next to point to one, right? This is what I need to do exactly, right? What I can write here is how can I connect them? I can write that mover. Your next should be temp. Won't that connect these two elements? Right? You guys are getting the point, right? Why, what is happening here? This will just connect this. So by writing this, you are just connecting them, and this will just, and the next of temp will obviously point to null because we have not tampered with it. But after this line, this will happen, right? The mover next is equal to temp, or in basically in Java you can write, instead of arrow you can just write mover dot next is equal to temp, mover dot next is equal to temp. Fine. This is how basically we will, this is how the next pointer works in linked list. This is how we connect the dots or the nodes in the linked list. Fine. Now, again, now these, we can't forget these elements as well, right? This is also somewhere, and they are also waiting for it, for getting connected, right? What I can do here is that I can move, as I connect, I can move my temporary here and mover here, right? In the code, I will code it out in such a way that after connection I can move my mover to the next element and temp to the next. Fine. uh, or how it will, but the temp doesn't know it's next, right? So we can't move the temp. So we will be creating a new element as 3, and we will define it as a temp, new temp. Fine. Right. So since you can't say that the temp dot next is 3 because there's no null, it will just point to null, right? Hence we will create, while creating a new 3, we can have it, we can say that this is a new temp, and we will just move the mover. Fine. So again we will repeat the steps, we will just again call this, right? And again it will connect these three values. Is that fine?
How did you update the mover to the next position?
It's easy. It's easy. You can say that here you can say that mover next is equal to temp. Since like in this case
No, that is for connecting the mover to the temp, right? Like linking it. After that, you told that the mover will
you can,
that.
yeah, I'm telling, I'm like re-explaining this thing. Like
Okay.
when we have this case, this connected it, right? Right. This connected it.
Yes,
Now,
yes.
now. Oh, sorry. Cancel. Now I can just in the like I can just write mover is equal to temp. Can't I write this? Mover is equal to temp. Is that fine? It's just
Okay.
simple as that. I'm
Yeah.
just, see, these are just pointers. You can point it to anything. When you write mover is equal to temp, it just goes here. Fine. And temp will maybe say, will stay somewhere. Also, this is something of a loop. We are again doing it as like we are repeating the steps again, right? So this is a loop. I will write the code, then you will understand this thing, right? But basically, we are this is how we are moving the mover temp point, right? Is that fine? So again, when I redid the step. I have pointing this to here, and this is again null. Similarly, this will same happen to the 8 pointer. So you guys understood the main connection, right? Is it fine till now? I will write the code as well, just to stay, just so that we stay on the same page. Fine. So let's quickly have one function convert to LL. Fine. This takes a vector int array. So basically what I have did here is that I have called one function. I have called one function convert to a linked list node star. Why? Because we are basically we will return head. Okay, one more thing. When this linked list will be created, fine. When this linked list will be created, in the answer you always return the head, the already existing head. Did you guys also see the significance of head here? In this question, the head is not moved or touched, right? As of now, it is not moved or touched when we are adding and connecting it. Why? Because head is something we should not tamper with, because head signifies what, how, where, from where the link list is starting. That's the reason we got the mover at first point. If we didn't have the mover, if we change the head, right, and in the at the end of the code we actually generally return the head. So this head would be pointing here, not here, right? So this will point 3, and when we return 3, when we return the head, it will just return these two elements, not these two elements. Did you get the point of head now? That's why head is really important, and we should not temper with it. We can create another, pointer variable mover as in here, right? That's why we create temporary and mover pointers. Is that fine? This is very important to note. You should not temper with head, because in the question also, like here I will return a pointer head only as an answer, so that it knows that okay, this is the answer, this is how the linked list is starting. Is that fine? Now, I will also, let's say that I will also make the head point, because in the data structure, in the declaration of the linked list, we don't have exactly the head, right? So I can have one, I'm making the first element. We have this array. Where was it? We have this array, right? So we need to make the head. What will be the head of it? 2, right? That's why we are first making this node. Fine. So hence and naming it as a head. Is it fine? So I can have new node, and this will be array of 0, because yeah, because this will be the basically the first is the whole node, right? Now also another thing, we will write mover. We'll write a mover which will be pointing to head. Is that fine? What we did here, first we have this head, new array 0. It will check what is the first element in the array. It is 2. It will write this. Now we also need mover, right? So as I have discussed the question, I am going in that flow only. So we have the mover. I have defined the mover here. Fine. Now I can have one loop. Int I is equal to 1. uh, I will be equal to array dot size, array dot length. Fine. Or I'm using C++, right? So fine. So I will be starting a loop, and I will declare one temporary pointer to again where in the array of I, because I'm iterating, because this temp will create the new nodes, right? As I go, as the connection happens, this will create a new node, right? That's why I'm defining it in this way. Just stick with this way. Fine. This will make sense, trust me. Now I have to move my mover dot next, arrow next should be equal to temp. Fine. This is how we connect. And after connection, what we do, we move the mover. We move the mover to the already existing temp, right? And after that, this loop will go on, and I will return the new head. I mean, the existing head, not the new head. Sorry, the existing head. Is this fine? This is how you will convert the normal array to a linked list in this way. Also, in if you guys are doing the Java, it's easy. You need to use int. You need not use to use the vector. You need to use int r, and what else? You should avoid using pointer here, and this will be moved dot next. Fine. This will be the for the Java one. Is that fine for now? Have any, does anyone have any doubt in this? We are just basically playing with these blocks. We are making a chain according to the question. Is it fine?
Yes.
Yeah, cool. So this is how we will be basically making the linked list. This is the formation. Now I will be discussing few basic operations in linked list. Fine. After that, I will basically what I am doing is that I am teaching you guys the tools to basically assume that is this as a game. Fine. I will teach you. I will tell you guys how to move. How to you know. Uh, I will teach you the controls of this linked list, like how to control it, how to move ahead, how to delete or insert, how to basically manipulate the linked list according to the question. Fine. And then using those tools, using those tactics, you guys can do any question. Is that fine? So this is what I will be doing in this class, in this session. If anything else is left, I will be making another video and will be posting next week, because next weekend most probably the class won't happen, because there is I will be out of station in the next weekend. So you guys will get more time to practice linked list, because this is actually a very heavy topic, right? So you should get more practice in this topic. Fine. Starting from first operation, very basic thing, traversal. Fine. Let me also copy paste this thing. Yeah. So traversal, how you will, like, as in arrays questions we discussed that how one can basically, traverse to the arrays, because that's how we also solve the questions of arrays, right? So in linked list also we should know that how we can traverse in a linked list according to the given scenario or anything, right? This is pointing to null. Whenever I'm writing this, just treat this as I am writing null. Fine. Basic guideline of today's class, of any class actually. Okay, fine. So here, how we can, iterate through the whole thing. Easy. It's very easy. I can have one head for sure. I can have one head for sure, right? Also, since I said, I have explained, you can't temper with the head. Fine. We will have another pointer. Temp, temporary. We can have another pointer, temporary. Fine. Temporary. So I will also code side by side. So when I am defining temporary, I can say that the temporary should still sit on the head. Fine. Should sit on the head. Let me, yeah. Now, I can basically, I can, while temp, I can say that, because when temp has some value, till then iterate through it. Basically, when temp has some value, it has some value. When it goes here, it will be null, basically, right? So till then, iterate through it. And if you need to, basically maybe just print the data values of the temporary, you can just see out this. And as you print out the values, you need to move your pointer to next, right? So temp is equal to temp next. Fine. This is how you will iterate. Basic operation. This is how you will iterate. It says that you need to move your temporary while temporary has some value. As it goes to null, just stop. So basically, it will just stop here. Okay. So this is how you will basic traversal will happen. Fine. Now, if you need to find the length, of any kind of linked list here, can someone tell how you can find the length of the linked list if we have this? Can you guys think, like, if you need to find, just, I mean, just treat this as an any kind of a array only, right? Because this is what we do in array as well, right? As the basically as any pointer or as anything, we need to, if we need to print the values of array, as the pointer does not goes to maybe increase the size of the array. Here we don't know the size, right, for now. So how we will know the size? Can't we have something as another, maybe counter? We can have one counter as 0. Fine, we can have one counter as 0. Again, I will make one more temporary pointer where it will set to head. Okay. Again, then while temp, I can maybe print the value, or not print the value. Let's say that I have as the temporary, as the temp, I need to move it, right? I have to move it to the next. Fine, I need to basically, what this means that if no someone didn't understood, like, let's say that in the first case, when I entered the while loop, in the first case it sees that, okay, temp, it says that temp go to, like, temp should be equal to temp dot next, which means that the what is the next of temp pointer, this, right? Hence this says that the new temp should be the next, should go to the next temp, next of the temporary, which is 1. Hence this is basically what the while loop is doing. And as the while loop increases, I can say that counter plus plus, just return counter. Done. This is how you will find the length. Exactly, right? It will go here, it will go here. You'll see that it is null. You'll just stop. This is what the size is. Right? Is everything
What is
is
the condition you put in the while loop? You just wrote temp, right?
yeah. So when I am writing temp, it just basically means that it should have some value. Okay, this basically means that this should not be equal to null. Is it fine?
Yeah, yeah,
Yeah,
correct.
I mean, generally this also means the same thing, but yeah, when I am writing while temp, which means that it should have some value, right? Is basically a short format, but okay, I will maybe write in this case, right? Now length is done, fine. Uh, Now let's say that what operation should we do now? Okay, let's say that we need to search. Yeah, search operation. Let's do the search operation. Okay. Uh, yeah, let's do the searching. Let's do the searching now. Fine. How we can search? Also in the question, let's say that again I'm saying that we usually deal with heads when in the linked list, so that we know basically where which linked list we need to find. Let's say that we have one check, when check func check function basically. uh, Here we are passing a head, basically we are just passing a head, that this is the head, this is of the linked list which you need to search. You need to search if this is some value or not. Fine, I just need to return 1 or 0 if the value exists or not. Fine, let's say that what we'll do here, we can have a temp which should sit on head. Fine, it should sit on head. And why now I need to basically it's very easy now. I guess you guys can even uh, understand that this is null. Fine. While temp is not, if like while the temp is moving, if temp if temp of data, here I am using data, right? If temp dot data is equal to val, what we do, return 1, because this signifies that this has some value. Also, as the while loop is going on, you need to update your temporary. You need to say that temporary dot next. Fine. Or else, if you don't find the element, just return 0. This is a basic function, check function. Fine. I don't think I need to explain much more in this. It's very easy. We are just dealing with the temporary. We are using temporary to just iterate through it. Fine. This is how every linked list will go on. Fine. Now, I think I can start with the deletion and the insertion. Fine. So, okay. Fine. Another operation, another very important operation, and using this deleting. Let me write deletion basically. So whatever you will study here, this is how you guys should also prac- uh, explain in an interview. Fine. So deletion. So deletion. Uh, when I say that you need to delete an element in a linked list, what all things goes to your head? I mean, let's say that the linked list is a long one. Let me also first of all copy it again. Let's say that we have this linked list only. Fine. Yeah. Okay. So in deletion, like when let's say that you are sitting in an interview round, and the interviewer goes like, you need to write a code to delete an element in a linked list. Fine. Now, by saying this one line, did you get like what exactly he or she is asking? Did you get the point? Not really, because when you say deletion, when you say delete one element, it can have multiple cases. It can mean that delete this head, right? It can also mean delete this tail, or it can mean that delete any element in middle of the linked list. Fine. So don't you think that if the question is like, okay, deletion, you guys, you can have multiple cases, like if like when the question is that you need to delete head, the code should be in a different way, should be a more optimized way. Like if the head is the deletion, like let's say that we need to delete the head, what we can do is that we can just shift the head. I mean, it is not. I mean, we don't usually deal tamper with head, but basically, but here in this case only, if it is written that we need to delete the head, we need to tamper with head, right? Obviously. So this head will have some different thing. Let's say that we need to delete the tail of the linked list. This will have another kind of code. Basically, we can maybe shift the tail and make the previous of the tail to point to null, right? This will be another thing. Now again, if we need to delete a middle element of here, right? This, for this the code will different. Basically the previous of it should point like in this way to the next one, basically, right? So you guys are seeing the point. All the there are multiple cases in one single line, right? So you need to, always in an interview, if the interviewer asks you only one line question, you need to form the cases, you need to, draw it out. For the linked list, you can't solve the question unless you draw it, right? You have to draw the linked list and then imagine that, okay, what can be the cases. If it is said deletion, I can delete this element, I can delete this element, I can delete the last element. So there will be multiple cases, right? So this is how we need to figure out the point, right? This is what was my point was. So was first case was deletion of head, right? Deletion of head. You need to form a code which can delete any kind of element. But to make that code, we need to consider all the cases, right? So that's why we start from the head. Fine. We start from the head. Now let's okay. So what can we do? As I already revealed what exactly we have to do. So basically we have this head, right? Why can't I just shift the head here, right? And also make this to point, update this next to null, right? Or maybe I can I will explain while with the code only, fine, or else you guys might get confused. Fine. So let's say that I have one I need to again in this question, what exactly I need to return. Can someone unmute? What I need to return in form of answer? Should it be array? Should it be some pointer? Should it be uh, a whole linked list or tail? What should it be? If I need to return, can someone unmute and tell? I have to return the new head, right? Whenever I'm saying that you need to, make a linked list or get update a new linked list, you need to return the new head basically. So we need to return the new pointer. That's why we write node star. Also, and let's see that this is a one function. This takes the old head. Fine. This takes the old head. Fine. Yeah. Right. Fine. Now this is done. Now node star I can have one temporary pointer to head. By writing this, I just declared one temporary here. I just declared one temporary here. Fine. I declared one temporary here. Now, what I can do here is that I can basically make the head pointer to shift, right? So I can say that, hey, head, go to your next. When I write this goes here, simply goes there. No question asked. This just goes there because it's head is just a pointer. It is just not, in the questions, it is not recommended to tamper with the head. But obviously for this, we need to tamper, right? So it's just a simple pointer. We can move it anywhere we want. So while doing this, we shift the head. Also, now we can, what we can do is that we can just make it, we can free the temporary, as in we can just delete this from the memory. Right. When I have written this, it, like when I have updated the head, it just points to nowhere. And this is how, I mean, let's say that even if it is connected, and I'm returning the head in the answer, what will it return? It will return it this thing, right? And this is what exactly we want, right? Is someone getting confused by this thing? No, right? Because we need to return the head. So even if this is connected to it, the question will return only this thing, and this is what we need, right? We need to delete the head. Basically, we need to just give this linked list, right? So but again, for good practice, it is recommended to delete this temporary head, right? So what you can do is that we can use something called as free temp. Again, this is only used in CPP, but in Java, you don't need to write this at all. You just return the new head. After that, you just return the new head and done. It's just done. Fine. In Java, you don't need to write this code, because Java has something called as garbage collector. Fine. It just see the unused variables, and just unused variables are pointer, and just deletes it from the memory, right? In CPP, you however need to write this free temp. Fine. Is that fine? This is the basic code of deleting the head of array. Also, one more case you guys should also consider. Like, if let's say that we need, if there's a linked list, if there's a linked list which does not have anything, if we have one, wait, yeah, let's say that we don't have any element in the linked list, we have nothing in the linked list, which means that if head is also equal to null, we just return null. Also, this is also is a base case, not base case, but this is a case which you need to consider, right? So this is another fourth case. So please make a note of this. This is basically how you will write the deletion of head. Fine. Now, coming to next, deletion of tail. Let's say that we need to delete a tail. Fine, delete a tail from the array. What we can do here again? Sorry, from the linked list. My bad. What we can do here now? Can someone tell? You just need to basically play with the linked list, play with the blocks, play with the uh, formation of this, right? So now basically we need to remove this 8, because this is a tail, right? What we can do here? Can someone tell? Just by words, not go to technicality, but just see what you have to do and what you can basically do to delete this 8 from the linked list. Can someone tell? Unmute and tell. Hello? No one? It's easy. Just see the pointer. If you need to break this out, right, what you can do? We just did this for the head, right? What you can do for here? Can someone tell? Think for a while. Can't we just make this the second last pointer to point to null? Won't that delete this 8? Is this
Yes.
fine? Yeah, exactly. So if we so you need to understand how to deal with linked list. You need to manipulate the pointers in such a way that it satisfies the question requirements. Fine. Here we need to make this 8 out of the linked list. So can't we just make the second last pointers next to point to null? It will automatically mean that 8 is no more in this linked list. This is just the linked list. Is this making sense to everyone? right? Is it's very easy. Linked list is not that much complex. Again I'm telling you that whenever you're practicing lead code questions related to linked list, or right now also you need to draw the linked list. You need to, for imagination, you need to draw in such a way that you know what exactly you need to do. Fine. So it's really important, really important to to use paper, pen, draw it out, and then solve. Fine. So this is what basically we need to do. And uh, let's say that we have some head. Fine. Here we have a head, and here we can have another pointer. Since we don't have already pointer in the structure of the linked list, we can have one tail. Right. Now we need to make it stop just like before the last element. Right. We need to make it stop before like last element. I will code it out so that you guys can understand it better. So I am again I have to return a head, right? So that the updated head. So I will have one delete tail function. Fine. This will take the head, right? Because this is how we give the linked list, right? Now, now, the first base case, if head is equal to null, basically we don't have anything to delete. What you do? You just return null. No question asked. Just return null. Fine. Or uh, basically also there's one more case here. Or let's say that we have just one just one element in the linked list. Let's say that we just okay, let's say that we have we have one. Fine. And this is a head of a linked list, and this does not have anything, no elements. Will this have any tail? You can't delete the head only because you need to delete tail. So this does not have any tail, right? Hence this will just return null. This will also, this condition will also go. Basically head dot next, head car next is nothing, null. Hence this will just return null because you can't delete head. You need to delete tail in this question, right? So this is what I meant by writing this one more condition. Fine. Now coming to the next coming to the next case, what can happen if there's a long linked list and you need to delete? So I can have one, again I can have one, let's say that I can have one temp. Let's go with temp only, right? I can have one temp setting at the head. Fine. Now I can iterate while temp next next is not equal to null, run. Okay, I will explain now. Let's say that, okay, this is a temp. Let's say that you need to, basically you need to stop where the next where the you need to make it stop, as in so that the next element is removed, right? You need to make the tail here, right? So can't you move it in such a way that this next, also this next is null? If you know what, like when the temporary reaches at such a destination whose next dot next is null, then stop. Doesn't that mean this? Okay, wait, I have written wrong way. Next, temp next is not equal to null. Fine. So temp dot next. So basically we can use this if we have, if I would have written this, where will be the temporary stop? It will stop here, right? Because it means that temp next, okay, next thing, one more next is not null, then stop. Fine, this will go here, this will stop if as like the next is not null, right? But for now I just need to get on the second last element. That's why I have written this. Is this fine for everyone? Understanding this, that dot next is not equal to null, then only stop the temporary, because we need to get here, we need to remove this, right? Now it's very easy. If we are at this position, like as we go, I need to iterate it, right? So basically I will just write the temp next. Fine. But as I have reached this temporary position, what you need to do, you can free the temp next. You can free the temp dot next, and temp temp next can be equal to null pointer, and you return the head. What I did here, oh sorry, what I did here is that first I saw that okay, I need to remove the tail of it. Okay, so the new tail should be this one. Fine, basically the last one. So can't I just make my temporary to go to the second last element? That this I guess everyone understood, like temp dot next, while temp dot next is not equal to null, till then only iterate. Fine. So it came here. Fine. Now I can free the temp of next. If you are in Java, you don't need to write, but again, free the temp dot next. You freed this, you completely removed it, and also temp dot next should be pointing to null. So basically, this is the new, and we just return the already existing head. So this is the new linked list. Is this clear to everyone? You can
Yes.
unmute and yeah. Still, you just look at this once and understand this. Fine. It's actually really, it's just we need to manipulate the pointers. We need to, iterate in such a way that it just goes to the correct position and just perform operations to complete the requirement. Fine. So this is the basics, the like basic operation, deletion of head, tail. Now, another thing which I explained in this, right? Deletion. You can delete the head. We did the operation. You can delete the tail. Okay, we did that code also. But what if the element is in between, like kth element? So now we will see how to delete the kth element. Then I will give you guys a break. Fine, there's a lot to consume today. So deletion of kth element. This is really important, right? This is the C part. The C part. But again, it's very easy. It's very easy. So let's say that we have one, two. I have another linked list. Where is it? Searching deletion now. Yeah, let's say that I have a new linked list. Fine, this is the new linked list. Yeah, so this is the new linked list, and we need to basically, let's say that we need to remove we are given a value, like in the question we are given a k value which is a 3. We need to remove the third element means this, k is equal to 3. We need to remove this element. So can now someone tell how we can I mean, not, don't tell me that how to go to that element and then operate the linked list. Just tell me that how the new linked list will look like. So okay, one, wait, control Z, 1, 2 and 4, right? This is how the new linked list will look like. Fine. What I should do here, like to as in the drawing form, what should I do here? Can someone unmute and tell? I need to remove this element from this linked list and make it in this way. What I can do here? Can someone tell? Anyone?
Like the pointer of 2 should point to 4 instead of 3.
Yeah, exactly. So this should not point to this. I mean, I should make it stop and point it to this. Right, exactly. Very good. So exactly whatever you said, this is what we need to do. It's as direct as that. It's just that the tough part in the linked list is that how to basically, how to use those tools to make this happen. Like how we can use another pointer and make this happen. But again, with practice and with my explanation, I guess you will understand it. Fine. Because like in count, two three pointers are there: head, next, and then there's previous. The in the linked list there will be something called as back pointer. So only those double linked list there will be back pointer. Fine. So only these, using these three four pointers only, you guys can solve any kind of questions. Fine. So this is what we need to do. We need to update this thing to this. But now again, like k can be given anything. In this case it is 3, right? Let's assume that it is anything. We need to go to the previous element of the given k and make that k dot next to point to the k plus 1. Did you get the k plus 1? Right, did you get the point? K plus
Yes.
1th element, yeah. Or instead of writing k plus 1, I can write kth, like this, the k minus 1th ka next dot next, like in previous one. I can write in anything, but for now I will stick with the
That
given.
k minus 1 to should point towards point to next dot next, like that.
Exactly, exactly, yeah, that's what I
Okay.
was saying. Yeah, exactly, kth ka next dot next, exactly. Let's see how we can write that as well. Fine. uh, Again, in this case as well, I need to have many cases, right? Let's say if uh, mm, let's say that what I can say. Yeah, one case can be that I will write it. I will type it. It's better to type it for now. I'm discussing now the cases. What if the k if the k is given more than the size of the or the length of the linked list? What if that's the case? Then don't delete. Obviously, you can't delete, right? Just return. You can write just return. Fine. This is just a basic, some use cases. Even in the interview question, you need to basically tell all the, you need to think all the base case, all the cases, not base cases, all the cases, and then work accordingly with it. But like, I can give you the k, I can let the size here of this linked list is 4, right? I can give you k as 6. Then what you need to do? You need to return nothing, right? You just return, you just write this. Fine, that's all, nothing else. Fine, this is one case. If k is equal to 1, what do you need to do? If k is equal to 1, can someone tell? If k is equal to 1, this basically means I need to delete the head, and we did the head. We need the deletion of head here, right? So why can't I just call it then? I can just call it as head. If k is equal to 1, what you do? Delete, delete head. Done. Nothing else. Nothing else. Now, if k is equal to what? Let's say that k is equal to the length. Fine. If k is equal to length, what you do? I am writing if k is equal to the last, which means deletion of what? Can someone tell? Deletion of tail, right? Tail. Just call that. Just call that function which we just wrote down here. Wait, where is that? I didn't. Did it got deleted or something? I think I deleted it by mistake. Okay, never mind. So let's go. Delete head. I guess I have written. In the when I will be providing you with the slides, I will write that function here again. It's is it fine? But you guys got the deletion of tail also, right? Cool.
Yes.
Yeah,
In
cool.
the sense only the last element, the last part
Yeah,
is
exactly, exactly. Yeah.
okay.
Now, only the last case which we need to work on. If uh, k exists between the one and it's greater and the length of it, then what we do? Now these are the cases which you need to tell to your interviewer that okay, we can have k as length, we can delete head, we can delete tail, but if it is exist in between, which basically we are discussing that only, right? But again, I'm telling you repeatedly to consider all the cases, because it's a good, it gives you a good impression in the interviewer, in front of interviewer. Fine. So if this case happens, what you can do here, let's discuss that now. Fine. I can have one more pointer here. Okay. Let me use this. Just hold on. Yeah. So yeah. So I can have one more pointer basically here as a pref, right? Using pref, I mean, let's say that this is the kth element. Again, I'm considering this case only. This is the kth element, and I can have one more pointer pref, which will basically, I can update this pointer to this, and this will go to, basic operation of the linked list, new linked list. This will be get removed, and I can update this next to be null as well. Fine. So this is what we need to do. We need to make one more pointer. So I will just code it out here so that it's easy for you guys. So I can have one again. In this case, I need to return the head of it. So I will write head. Basically the pointer. I need to point. Head is a pointer, right? So delete kth. It will take the already existing head where it needs to get performed. Also, I need to give the k, obviously. Fine. Now, if again, if the list is empty, if the head has not is doesn't have anything, what do you do? You just return null. Fine. I'm writing this again and again because this is a very basic case. If I guess you guys understood that if head is equal to 1, or sorry, not head, if k is equal to 1, what you do? You return with the delete, delete head. Fine. Just do this. Right. Or else you can maybe have that if k is equal to length, but to write this length, you don't have anything length as in length given that, right? So we won't be writing this. If you guys can maybe make another function of length, fine, and then call that if k is equal to length, then return the delete tail head. Fine. So you guys can do that, I guess, because I have explained the length thing. So just return delete tail. Fine. These two cases are there. Fine. Now, I can have one count. I can have one count variable. Fine. I will have one more pointer, like the new case pointer, as temp, node star temp, which will sit where head, and I will have one more thing which is called as pref, null. Basically, it will just be a null. Fine. Now, while temp is not equal to null, basically, while it does not goes to the last element, so like count plus plus. Fine, you need to count plus plus as you go. Fine, as you go, you count plus plus, and um, if k is equal to count, then start deleting that. Fine. So basically, what we did here is that to get the k, to go to the kth element, to go to the third element, to the third element. Where's my yeah? To go to the third element, what we did is that we made one counter, and as the temp was going, count was incrementing, like 0, 1, 2, 3, third. If I'm starting with the third one, I should write count as 1. Is that fine? This is how you need to think. You need to basically fix some errors and debug, right? So if k is equal to count, as in if we have reached to that particular node, what you do, you make the pref next is equal to pref next next. What I did here, what I did here, let me show you again. I just did, erase, let me erase as well. What I did here is that I went to, this is okay, I made myself here, and then I said that, hey, Pref, your next, Pref, your next, your next pointer, this pointer should point to, should equal to Pref, next, next, basically, I mean, next, next. This pointer should be next, next. Got this point?
But for that, prev also needs to be updated, right? To the position like k minus 1. Then only. Your still prev is null. So it is still 0.
You can update this as well. Oh yeah, you can basically what you can do here is
Like
that
it should reach to the k minus 1 position, right? For you
yeah,
to
yeah,
get
yeah,
the
yeah,
update.
yeah. Oh yeah, 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 yeah. So you can update the key as you can update. Let's say that we have the you can make okay. So how you can update this? Let's think that as the temp goes, pref should be beneath like below basically pref dot next should be equal to temp, right? We can say that because in this case the pref will always be like behind this, right? So we can update it in this way. Yeah, I missed that. Pref dot next. Yeah, exactly that thing. Uh, yeah. So in that way, I can make my pref to be just like behind the kth and then just do this operation. Fine. Is this fine now? Pref dot ne is it, like pref's next should be pref's next dot next dot next dot next. Fine. So this is what we will do. Yeah. Good point. So this is what we do. Now, as I had did this, I can maybe break it right now, and I can make my pref this. I can yeah. Instead of this, I can write the pref here as well. This basically is inside the temp only, right? So as I'm going, I am making this like as I'm going, I can make this as a temp only. So I can write it in this way as well, right? So temp, I can update this to next because this is going, else return head. Is this fine? What I did here is that I just broke out of the statement. Like if you got this, just update this prev next and just break out of this statement, which means that just return the head. Fine. There's no indentation formatting in this board, hence I need to you need to understand in this way. Like this is the another loop, this is the inside loop, and this is the last loop. This is a while loop, and this is the if loop, if ka loop. Fine. So this is how we will go with it. Fine. Instead of writing that, I can write this as well. If you think, if you debug, or whoever asked that, if you debug, if you basically try run this code, you can, while temp is not equal to null, you can say that prev is equal to temp as well. As the temp goes, you can say that temp as well. This will keep the track basically, whatever you were saying. Fine. And temp
Okay.
will be equal to temp.next basically, which means that let's say that this is, let's say that this is basically the scenario that temp is here. Okay, let me, because this might be confusing. That let's say that we have this case that in the while loop temp is here. Fine, temp is here. Now, if I wrote prev is equal to temp here, I can see that prev is equal to temp. Basically means that prev will sit on temp. Now, after that only I'm saying that temp should be equal to temp dot next. Basically means that temp should go here. The new temp, the temp will get updated. Doesn't that mean prev is ultimately behind the temp? Is this
Yes,
fine
yes,
now?
yes. Yeah,
Yeah,
yeah.
yeah. Is this fine? Because this is the better way to write this. Because this will keep the track of both of things. I guess that will be good, better. Fine.
Yeah,
So this will be the code. This will be the for the deletion of the kth element. Right. I have covered all the cases. If the case one, length, this, blah blah, everything. So this is how you will cover this whole thing. Is this fine now? Uh, if you guys want a break of 5 minutes, you can take that because I guess it's a lot till now. So yeah, let's meet at 10:35, I guess. Fine. Right now it is 10:30. Let's meet at 10:35. Take 5 minutes break and just see whatever like I told, whatever I explained. Yeah, so we will be returning in 5 minutes. Fine. Yeah, so now we will be starting with the insertion. Right, so this is done. Wait, let me clear my board as well. Some garbage here. Okay, let's start from here only. I will copy. Am I audible by the way? I guess I'm.
Yes, yes,
Yeah,
yes.
okay. So, deletion of. Yeah, let me copy paste this. Cool. Now, deletion is done, right? So now we will start with insertion. Insertion in LL, linked list basically. So yeah, we will start with the insertion now. Again, we might need to tackle with many cases here, right? So basically, we can, meaning that we can have a new, we can have a new node inserted at maybe at the first, or maybe at the end, or maybe in between, right? So there are again three cases which we need to discuss here. So starting from, I mean, again, it's very direct, so I will be just starting like the thought process I told you guys, like how you need to think. But now let's just start. Let's say that we need to insert at head. We need to create a new head and insert, right? So let's say that I have. So let's say that I have, right now I have this. I need to basically insert a new element which goes, let's say this, and I have to have 5 here, right? So, and also this is head at present right here, right? This is head. So what we can do here is that it's very easy. We can, I mean, we just need to manipulate. Right now, this will be pointing to null, right? What we need to do, it's very easy. We need to first update this pointer, make this head come here. Done. Nothing else. Nothing else. How we can do this? Let's discuss. Let's see. I can have, first we need to create a new node basically, right? So for now I will just insert head, right? I can have new uh, old head, fine, and the variable will be in this way, fine. This is what the function will look like. I can just return the new node. Okay, just return the new node value with the head. Can't I just do this instead of, I mean, basically what I did is that if you remember that function which I wrote, the node in the structure, I'm just basically updating this to a new val, right? Also after creating this, I'm just updating it to the new val head, right? So it's just that new thing has been, basically, if this is a linked list, there's a linked list, and we have some node, we can just make it as a new head, right? It's just that simple, because again in linked list, if we make our head to point to anywhere and just return that, it will just return this new linked list. This is what we do, right? We don't exactly need to just point it and all that. Just make it as new head, and then it will just return everything. Fine, because we are just creating it. New node has been, like, we are using the same function, hence it just works. Fine. So this is the basic function of insert at head for now. Now let's learn how to insert at the end. Insert at end. Fine. This we will discuss. Fine. But again, I will just tell you the approach. You guys need to code it out, right? So again, here as well, what I can do is that uh, I can first. This will be your homework. Second homework. Let me. Yeah. What I can do here is that I can do is that again. I can. This is head. This will be head. I need to. I need to insert a new element here, and this is actually pointing to null. I need, and this is also null. I need to perform something that this gets added here. What you can do here is that I will just give you a hint, and then you guys can solve it easily. I can have one new temp here, right? I can have new temp. This is homework for you guys. Code home. So what I can do is that I will just tell you the approach. I can have one temporary variable. Fine. I can make it move just here. Fine. And then what I need to do? Simple. I just need to make say that, hey temp, listen, you are right now at here. Make your next two point here. Done. And this null. Done. This is how insertion at the end will happen. Now again, the code will be your homework because I think it's pretty much I have discussed everything with you guys right now. I have discussed how to move this temporary to here but at any condition, at any particular location I can move temporary, and then this connection I have discussed. So this code will be your homework. Fine. Now so like one, so we discussed the head insertion, tail insertion. Now what if we need to insert at the middle? Fine, now let's discuss that as well. Can fine. This will be C, insertion at kth element. Yeah, so similar, quite similar with the k, with the basically kth element, with the deletion of the kth element. Fine. So let's say that we are given this linked list and we need to make one insertion, but where we need to insert it? Let's say that uh, we need to, let's say that the k is given as 2. We need to insert it at position 2, right? And the element is given 10. Fine. What we need to do here? Simple. Can someone tell? Quite easy. We just need to play with the point ones again. Wait, something is hanging. Am I audible, by the way? My laptop is a bit hanging. Hello?